Hi guys, I'm back at the bench. Today we're going to have a look at some basic test equipment and how I use these tools to diagnose an amp. What I have here on the bench is a Mojotone 45 kit. It was built by a local player here in Melbourne, Australia, and he has sent this in to me, or he dropped it off for me to take a look at. So basically he completed the build himself, got it to the point where he kind of got to the first power on of the amp, and I guess, got a little bit unsure about about what to do next, and how to start this thing up and test that it's all okay. So I thought this would be a good test case to show you the kind of routine that I go through on first power up, and how I used a digital multimeter to diagnose and check some basic voltages in the amp. I'll do a second video on the same amp, and we'll have a look at how I use the oscilloscope here to test the signal path through the amp, which is a great way of diagnosing faults. Just a quick note about how I set up on the bench here, right guys? So I have an 8 ohm resistive load sitting here, right? It's actually connected up. This is a speaker cable that connects up to an 8 ohm fixed resistor that I've got screwed up on the wall here to keep it away from the bench. I made the mistake of having this down on the bench. It gets hot, and you want to keep it away from wires and so on, right? So I've got it up on here, out of harm's way. I always have on a power up that plugged in. Provides a load for the amp, which is obviously critical. If anyone knows anything about tube amps, you never turn them on, well, out of standby, without a load plugged in. Always a good idea. I do have a speaker cabinet in the room here that I can use, but I only get to that point once I'm satisfied that we've got an amp that's going to work. So I avoid, making loud noises unnecessarily. So let's go for a first power up. I'm going to turn the amp on and then leave it in standby. And the first thing I'm going to do is just check out a few voltage readings. Let's do that now, right? This is a first power on for this amp. I have actually just kind of been through it visually and checked that, as far as I can tell, the cursory kind of glance, that it's wired okay through the power section, through the the power supply section, that is, right? It's a tube rectified amp. It's a JTM45 clone. Interestingly, the Mojotone kit comes with EL34 power tubes, which is kind of interesting for a JTM45, and a Plexi 50 watt output transformer as well. So I'd kind of call this amp a bit of a hybrid JTM45 50 watt Plexi. So be that as it may, let's turn on the power. Okay, first thing I look at, the indicator light is going. That's good. The second thing I look for is glow on the tubes, right? So it's a very quick visual indicator to see whether or not we have heaters working, and I can see the two power tubes are lighting up, and I can actually sight straight down through these preamp sockets, and I can see all three of them are glowing. So that's good. So the next thing I'm going to do is I'm going to measure the heater voltage. All right, so I'm looking for 6.3 volts AC, right? So set your meter to AC. Right, it's the one with the V and the squiggly line. You have to measure the heater voltage across the two heater pins, right? Don't measure it to ground. You can measure it to ground, but you won't get 6.3 volts, right? You'll get half that reading. And if you've got DC elevated heaters, you'll get some other weird thing going on, right? So take any power tube, any tube socket, I should say, and just measure across the two pins. All right, so I'm going to measure from here to here. And you can see, if that's coming through in the video, I've got 6.85 volts AC, which is, that's okay. Right, a little bit high, but There's no load on the power transformer at the moment. My wall voltage might be a little bit higher than 240 volts as well. I haven't checked that. But yeah, 6.8, that's fine. Right, the second thing I'm going to do is I'm going to check for a negative bias voltage on the grid of the power tubes. Always do this before you take your amp out of standby for the first time. Right, it's critical. If you do not have a negative voltage on the grid pin of your power tubes, it's got to be in the order of, let's call it minus 35 to 40 volts, somewhere in that range. Maybe as low as minus 30 to begin with. If you don't have a negative voltage on there, what's going to happen is when you turn your amp on, your tubes are going to run away. They will red plate, right? They will red plate within a matter of seconds, and if you do not pull the amp back out of standby, you'll be buying yourself a new set of power tubes. It's an expensive mistake. So we're going to move the meter into DC, right? Flat line. Get yourself a ground. I just stick the black lead in the meter just into the chassis like that, right? It's fine. When you're measuring voltages inside your amp, one hand, DC voltages, right? Now, I don't have the amp out of standby, and I measured the headers with two hands. I knew, right? There's no high voltages in here yet because the amp is still on standby. But always good practice. So one hand away, one hand on your on the probe, and I'm going to check for a negative voltage on the grid of these power tubes, right? It's pin number 5, and you can count it from the bottom. 1, 2, 3, 4, 5. Okay, it's the one here with the grid resistor. Often this will be a 5.1k resistor, somewhere in that region, right? Maybe 4.7k. Sometimes as low as 1.5 on some amps, but it's normally around about 5.6k. So if I hold the probe on there, what have I got? Look at that, I've got minus 35 volts. That's good. That's really good, right? Check the other one. Minus 35. That's cool. All right. That's actually been fed from these bias resistors up here. These 220k resistors. I don't know if you can see that on the video there, but you'll get it up here, right? This is minus 35 at this point in the amp. Now, obviously with this Mojotone kit build, we've got a turret board layout that is largely taken from the Marshall layouts before they went to PCB based design. So many kit builders, you've probably got an amp like this at home that you built yourself, whether you got it from Stereotone or Mojotone or whatever, right? So I thought this amp would be a good reference point because a lot of people starting out building amps might have a setup that's quite similar to this. So yeah, you'll notice on this amp, right, this end of these 220k resistors here, which is setting up the bias voltage. If you follow the wires, you'll see that they come across underneath the board and connect to through these 5.6k resistors into pin 5 of the power tubes. Okay, that completes our rudimentary checks before I'll take the amp out of standby. All right, well, we're ready to take the amp out of standby. I'm still holding my digital multimeter here because what we're going to do is we're just going to check the amp's voltages, right? So we're going to check the B plus supply and through the basic nodes on the power supply string, right? So we'll go plates, screen supply, phase inverter supply, and then into the preamp supply. I'll do that across the board. And then the next thing, if that all kind of checks out, I'll be looking at the voltages as they actually are on the pins of the tube sockets. And the very first thing that I do when I take it out of standby is I have a look at what's happening on the power tubes. So we've checked the grid, the bias voltage on the grid resistors, or the grid pins. that was minus 35 volts. That's good, right? But always check visually. You do not want your power tubes to red plate. So we're coming out of standby here. There we go. Okay, so far so good. It can take a little while for that to happen. Often if it's red plating, you'll hear the power transformer start to hum, because if the power tubes are red plating, it means that they are just running away and drawing as much current as they can from your PT, and the power transformer will start to make a noise. You can hear it, even though we're not plugged into a speaker here. You'll hear the mechanical noise from the PT. This all sounds fine, and I don't have any red plating going on, so far so good. Okay, first thing I'm going to do is check the plate voltage. Now the plate voltage, your B plus line, it's called the plate voltage because it's the voltage that's applied to the plate of your power tube, right? Or the anode. It's pin 3, okay, pin 3 of the power tube, and your power tubes get that B plus DC voltage via the output transformer. Okay, so the output transformer, the primary side of the output transformer, you'll have 2 anodes and a center tap on the primary side of your PT. Each side of the, your OT, your output transformer, each side of the primary wind on the output transformer goes to pin 3 on your power tubes, right? You probably already know this. And the center tap will be connected to that B plus line, in this case via the standby switch, which is also connected to the first filter cap in the amp, right? So this is where, you know, we've now got, we should have a fairly stable DC signal if everything's going well. So let's measure it, right? So pin 3, I can see it right here. 447 volts. For a JTM45, that's pretty normal, right? Bang on, I would suggest. So that's pretty cool. I'm going to measure the other power tube now, pin 3 of the other. I'd expect it to be basically the same. Oop. 446, okay. So that all looks pretty cool. I noticed that on this build we do not have 1 ohm resistors to ground, right, through pins 1 and 8. Obviously a 1R resistor allows us to measure the bias current by taking the voltage reading. This amp does not have that installed. That's okay. I have a bias probe. I'll need to get that out and use it. I'll show you how I do that actually, because it's the only way. When we don't have 1 ohm resistors on here, it's the only way of measuring the bias. Okay, the next thing I'm going to do is I'm going to check the screen supply. Now the screen supply is also on the power tubes, and it runs to pin number 4, and I'm expecting this to just be a few volts less than the B plus line. 426, probably lower than I expected, which might suggest that the bias might be running a bit hot. So I do need to check that. So that's telling me that at idle, these tubes, power tubes, are pulling a bit of current. So we will check that. The next thing I'm going to check is the phase inverter supply node. So that should be here. 360 volts, I saw that. Okay, so this is where we have a 100k resistor and an 82k resistor that come together, and you often see like a 47 picofarad, often called a fizz cap, sitting here. This is the supply. Those two plate resistors, the 100k and the 82k, are supplying, you know, the other plate resistors for the phase inverter tube, and they're their supply line, their B plus line is where they come together there, right? 360. I can see, because the way this amp was built, the power supply lines are sitting on top of the board. So if I follow that red wire, I can see to one side of this, what looks like a 10K resistor, big 3-watt resistor by the look of it. There's my 360, or close to, and so I can measure the other side of it. Now we're into the supply for the preamp. Okay, and so I've got, what I'd expect is a decent voltage drop across that 10K resistor, which is going to the supply for V1. Okay, two 100K plate resistors there, and V2 being a cathode follower, I can see this blue wire here, right? It's coming straight off that supply B plus line as well, 305 volts, and it's going straight to V2 as I'd expect, and the 100K resistor which sets up the cathode follower supply, or the supply for V2A, okay, this side of the triode, that's sitting there and working as I'd expect as well. So far so good. We do need to check the bias, so let's do that now. So I've now connected my bias probe to one of the power tubes, so we'll be able to read a current in milliamps off my second multimeter here, right? So this is kind of one of the, probably where I started out with the multimeter game, a bit of a cheaper one. But I have my bias probe connected to this setting up in a milliamp reading configuration, and it's a pretty handy thing to have. So I've got my DC volts here, which I'll be checking plate voltage with, and I've got my bias current here. So let's power the amp on, take it out of standby, and let's see what happens. Now our plate voltage was, from memory, 460, somewhere around there. I'm expecting an optimal bias current to be something like 35. Oh, look at that, it's already well over 40. And I thought that because the voltage drop from the plate to the screen was very high, which would suggest a lot of current. So Ohm's law, right? V equals IR. If the resistance is a constant and the voltage is high, it would suggest that I, being current, is also high. So a voltage drop across a resistor, if it's high, it would suggest that, or higher than you're expecting, it suggests that the current is flowing more strongly than you expect. So I'm adjusting the bias here now, bringing it back down. Sort of set it at about 35, I think, to begin with. So what's our plate voltage? Let's check that. 455. Okay, so 35, I don't have my calculator here in front of me, my bias. I normally use an app on my phone, but I'm using my phone to record this video. But I know that, that it's pretty ballpark to get, let's just, get this amp off the ground. I will fine tune it once I am happy that the amp is in kind of okay working order. Now, if I just check the screen voltage on pin 4, it's 443 now, right? Compared to, here's our plate voltage, 455, and the screen voltage, 443. A much more reasonable voltage drop. I can't remember what the reading was first time around. We'll go back and look at the video, but it was quite a substantial voltage drop from plate to screen, and that surprised me. That's looking kind of much more what you'd expect. Okay, so what I'll do now, I'll just kind of leave this on. Always check your bias, by the way, when you're doing a bias reading like that with the amp on idle. Just make sure your volume's down. Right? You don't want any kind of, you don't want your amp doing anything other than just sitting there. No inputs going in, everything grounded, volume's on, you know, minimum. I put everything else on midday, tone stack and everything. I'll just put it at 12 o'clock, but your volume's down. Now, what I'm going to do now, I'll put that back in there, is I just want to check the voltages coming to each pin on the anode and the cathode, or the plate and the cathode, which, you know, using kind of contemporary wiring coloring, you'll often find blue for plate and yellow for cathode. This has been followed in this amp, which is handy. I can see that V1 has got a shared cathode, which is very JTM45. So there's definitely JTM45 elements to this amp. So let's check our plate voltage here. Pin 1, this is V1A. I've got 206 volts, right? I've got a shared cathode. That looks about right. When you measure the cathode voltage on these preamp tubes, you're only expecting, you know, 1 to 2 volts, right? Somewhere in that region. Plate voltage on the other side, this is V1B, 200. I'd expect that, right? Both sides of this V1, both triodes, have 100k plate resistors. Here they are here. So, you know, given that they come off the same supply, which is our 312 volts here, you'd expect either side of them, given that they both are using the same cathode resistor, to be the same. Just on inspection, okay, I have noticed one problem with this amp. I just checked it in between filming these little clips here. The first preamp node, well, when I say first, I mean like the preamp end. So this power supply node right here, which is our 311 volts, which is setting up the B plus line for V1, it does not appear to have a filter cap wired to it. Okay, so I'll need to check this out, and I'll reference it against the schematic for this amp. So I'll need to check that, right? So just in terms of debugging this build, the next thing I'm going to do is sort out the filter cap. So I'll do that before we get into checking this thing out on the scope, and that'll be the subject of a second video to come. Today was all about using your multimeter to check out your amp on your first power up, or maybe you've been using this thing and you've never checked your voltages properly, and you want to go through that routine. Alright guys, hope it's helpful. Stay tuned, keep an eye out for the oscilloscope video. It will follow this. We'll use the same amp once I've ironed out a couple of the kinks in it.